So anyway, I think it's super interesting that we know that this is how we use these functions in the real world. You'll notice people who collect data, and we notice trends, we notice something happening, and then we have to put like a model to it. We're like, oh, does that model a line? Does that model an exponent? Does that model a parabola? And is it perfect? No, because you have things that are unpredictable. You have those weird rises and then weird drops again. But models are still a good way to make predictions. And so we do have some outliers and some things that kind of like throw off like the trend, but for the most part, it did look like it was following an exponential model. So then you can come up with an equation. You guys can come up with how that equation works, and we use those models to plug in, a different year and to be able to make future predictions. Okay, and that's what they really are. They are predictions. Today, we will be introducing some exponential functions and models. And this isn't erasing for me. That's okay. And you guys are going to notice that we have a basic formula for you to follow. And you guys have to assume that these models kind of have already been built for you. So you guys were kind of just like reasoning and kind of be like, what does this line look like? And then once you see this line, then somebody would put together an equation that represents that line, okay? Well, for today, we are going to be giving you guys some easy formulas that you're going to be plugging into already. So we're going to already have that model built. Does that make sense to everybody? I feel like it's important to know that formulas are there to use, and I want you guys to be able to utilize those formulas and solve for the missing pieces of information. And it kind of, came from somebody else kind of building that model for you, okay? All right, we're gonna hurry and talk about the part that we haven't talked about. We have technically solved every single function you're gonna have to solve. However, we have not had to solve, so last lesson was solving logs, and where a log wasn't necessarily equal to a log, and now we're gonna have to solve exponents. And so we didn't solve exponents yet. And today, your guys' applied problems are all going to be in exponential form. And so you guys are going to have to be able to solve these kind of confusing problems that seem confusing, but you guys actually have the skill set to do it, okay? All right, so let's just quickly reminder that around the world, b raised to y was equal to x, but we're going to be going the blue direction. We're going to be going from this one to that one. And this is the harder direction. I feel like going from exponent to log is a little harder. So when I go to write it, I usually start by writing a log and then a base b, and then I start doing what was stuck up in the log. Oh, now it's alone. What needs to be in the, what was stuck up in the exponent? Oh, the y was, and now what was alone is now inside the log. So make sure the conversion works for you. I think this is the harder direction. So I'll actually have multiple ways for you guys to solve it. All right, so today, you guys are going to isolate the exponent term, make sure even like numbers out front need to be moved, like those don't get to times together, they need to be taken away. Anything stuck up in the exponent can't be taken away until you get rid of the b, so that has to stay, but anything that's being added to it needs to be moved. All of that needs to be isolated until you just have your exponent term. That is where you guys are going to either convert it to a log, or you guys can do the balanced equation way, where we actually are going to teach you how to log both sides. You can log to clear the exponent. And so you're going to have, I kind of told you guys I don't like to withhold methods because I feel like you should have more strategies. I love how in the elementary, my child is now coming home with multiple strategies to do things. They are coming home with like, oh, you can add and subtract this way. You can multiply this way, or this way, or this way. And that's kind of like, I know sometimes teachers withhold confusing you, but I think if I give knowledge is power, you guys can learn and choose which way you want to solve it. So I'm going to teach you possibly 2 to 3 approaches today, okay? Finish by solving. You should be in a habit of checking, but do you guys think with exponential models where the domain on exponents was all reals, wasn't the domain all reals on exponents because their graphs look like that? You won't run into extraneous solutions as often. So checking is mainly to think, oh, did I mess up? Okay, so I'm going to say, yes, get in a habit of checking, but you're not going to really run into, oh, yeah, this is extraneous. You're not going to run into them because there's no domain restrictions. Okay? All right, let's go ahead and do just a couple so we have them in your notes. One will be from your homework. One will not. I suggest you put them both in your notes for the group test, but if you want to make sure you have one done, then great. All right, let's start solving this. Hurry and turn and talk if you don't really know, but what would you guys do first? Tell me what your first approach would be.
Isolate.
Isolate by doing?
-5.
Minusing a 5. Good. So everybody hurry. I was trying to see if I could erase something. Everybody minus a 5. Is our exponent term technically alone? Yes. Is this the same as the day we learned this? Hey, if my basis can be written the same, let's just write them the same and let's just say x equals y and then we're done. Is this one that can be manipulated that way? Can we use this property? No, 20 cannot. When I factor 20 down, 20 cannot factor down into something that's multiplied multiple times. So it's because it's technically 2, 2, and, or sorry, I'm not talking and not focusing on what I'm actually writing. It's 4 and 5. So this can't be written as something squared, something cubed. It can't be written as a base 2, right? So you can't use this. Well, now what? Okay? We'll turn and talk. Will you guys find a way that you want to? So hurry and turn and decide how you guys would do that. For some reason today's printed on me. Hurry, do your first step or your next step and tell me what you think would do. Okay, is anybody brave enough to tell me, did I give you one?
Yeah.
Is anybody brave enough to tell me what they did? Or if we got stuck, it's okay too. Time.
You log it by putting the 2 as the base, the 20 next, and then equals to 4x.
So you're doing the convert way. Let's do the convert way then, like he said. I'm turning it to a log. You said the 2 is the base.
Mm-hmm.
What goes in here?
20?
The 20, and now
4.
the 4x was freed. Remember what was stuck is now unstuck. Because 2 was raised to 4x and they're equivalent. And if you guys did the AI, the school AI interaction, you guys learned that logarithms are just repeated multiplication. They're just exponents, right? And so that's why we have this property that you can convert. All right, what would I do next to get my answer? I want to be able to get an answer, like an actual answer I put in my calculator. Anthony, you know.
Is it log 20 divided by log 2?
Very good. This goes into your calculator as log 20, and it can be ln's also, but we can say log 20 over log 2. This is called your change of base formula, and this is how you have to evaluate it without being able to manipulate the 20 to be a 2 exponent. And so this goes into your calculator. Don't forget to close parentheses before you divide by log of 2, and that's an allowed property. And then what would be your final step to get x completely alone? Divide by 4, and whatever this number is in your calculator, you also divide that by 4. Does anybody mind telling me that this is when I'm okay you round? I would always leave everything in your calculator till the very last. Try not to round sooner, because if we're going to be working with sometimes exponential growth and decay, you could be off by a lot of years, for instance, if you round too soon. So anyway, what would you guys get here? 1 point. Let's do 2 decimals. 0.08. If you did not get 0.8, 1.08, will you just raise your hand and I'll come and see how you entered it and try to figure it out. And while you guys are all finding the answer, we're going to actually do another approach so that you guys have multiple ways to understand. This was the converting way, by the way. So those of you who are putting in your notes, this is us using the convert to a log. All right, is there anybody who wasn't able to get 1.08? Okay, this other way is using the equation as a balanced equation. So for instance, does anybody think what I could do, you know how when we solve, we've been using inverse operations. When I add, if I have a -2, I add 2 to both sides. If I had x squared, I square rooted both sides. What could I do to both sides if I wanted to clear an exponent base 2? You can close. Division doesn't undo exponents. Division only undoes multiplication. We can, square rooting only undoes squaring. So see how they're all inverses? Logging is the only thing that will undo an exponent. Okay? So you technically could log it. I could log this. And I could log what I do to one side, I do to the other. Okay? This is actually not taught in very many cases. A lot of teachers don't. They only do the conversion way. But watch what happens. When I logged this base 2 with a base 2, didn't it just clear?
Yeah.
And what do these turn out to be identical or to be like? Identical.
Yeah.
So if you guys choose to log both sides with that base, you are more than welcome to. And the other approach is when you log something, it allows you to invoke the log property of you pulling that out of the exponent. So you guys can also log with a regular log or log with an ln. In fact, in science classes, you guys use ln's when you go to solve equations a lot. Anybody remember in science classes trying to solve some type of like bacteria growth and you used ln's to solve? Has anybody gotten to that at all? You'll hopefully see some overlap someday. So the other approach when I was at this 2 to the 4x equals 20 stage is I could say, do you know what? I need that unstuck. I need that out of the exponent somehow. And so some people might think, well, I'm going to log it because I'm going to log with either a log base 10 or an ln or whatever because it'll allow me to pull that out of the exponent. So this is another approach. I could be using an ln to both sides or a log or anything I want. Just log it. And when I log something, I can pull the 4x down. Now ln of 2 is just a number. Treat it like it's a number and treat ln of 20 like it's a number. What would I do to get rid of stuff that's stuck to the x there now, that's timesed? I divide because they're all times. If I divide by ln of 2, that clears my ln of 2. I can also divide by a 4, so I could have just done it at one time, which we were going to divide. Isn't this the exact same thing we just did over here? Log of 20 over log of 2, but then we're also dividing by 4, which technically can also just be there. Isn't this what we did over here? Log of 20 over log of 2, and then divide by 4. Ln of 20 over ln of 2, and then divide by 4. It's the same thing. So whatever way you guys like, you can actually do it. You guys can convert, you can log with the matching base, or you can just ln so you can pull stuff out of the exponent. So bringing logs into the picture allows you to use log properties now. And so that's also another method. Kind of cool that you have a lot of different ways to approach it. We're going to try this on your homework. I'll let you guys choose to do it in your notes so you have it in your notes, but if you want it directly done on your assignment, that's fine. And I would love for you to turn and talk and help each other. So let's take just a moment that you are working together to knock out number 12 together, and then we've got to get to the applied problems. All right, I'm kind of going to bring you back, and let's see. Hey, how are you?
You guys know it.
So what was some of your guys' first step? What stage? Talk me through it. Anybody can talk me through it. You're even welcome to come right on the board if you want to move your legs.
Oh wait, no.
First minus the 2.
You would, okay? Is anybody brave enough to come up and just do the problem? I don't mind if someone comes up and writes for me. Anybody want to? No? No? Okay, what did you guys do next? Did anybody turn it to a log at this point? Okay, did anybody clear anything else at this point? You should divide by 4. So, if you didn't, you technically can't convert it to a log because that's in the way. Does that make sense to everybody? So you can't use that around the world property till that's gone. And so if you didn't, go back and switch your work. Let's divide by a 4 to get rid of it. Now my exponent is finally, what did you guys get when you divided by 4? So, okay, if it's a terminating decimal, I am okay you write the decimal. If it wasn't a terminating decimal, don't round it at this point, okay? All right, so how you guys hopefully are at this point. Who made it at least this far? Good. Did either of you who raised your hands, did you guys get further beyond this?
I converted it.
You did convert. Good. So if you choose to convert, how are you mentally converting these? How are you doing it?
I did ln and then 44.5 equals x.
Good, so you chose ln of 44.5 equals x. But let's backtrack. We would normally say, all right, this is a log base e. E was raised to x, and that was equal to 44.5. So like if we do that, right? We're like, oh, it was raised to, but we don't write things as log base e, we write them as ln's. Okay? So I'm assuming that's the process that you go to. And at this point, when you guys have something paired with an ln, you've already found your number. So the exact answer is ln of 44.5, and your rounded answer is your decimal. And if you guys don't mind telling me the decimal to like maybe 2 decimal places, that'd be great.
3.7. Well, actually, it could be 3.80.
You think 80? Perfect. Is everybody getting close to that answer or getting that? Awesome. Now, she did the converting way. If you guys want to do it the balancing equations way, you can take this 44.5 and with ease, because they kind of are a little tricky to wrap your head around when you're converting, I just ln and e and it clears it. And so that means if I just ln both sides, that is the same thing as me kind of converting it. It gets me to the exact same point. And so, thank you. So I just ln both sides. That's what I would do because it's just as easy. All right, do you guys feel okay with that? Now I want to show you, you guys are going to have to solve for our compound interest models for stuff that's up in the exponent. And I want you to know that you know how to do it, so don't overthink it. We know how to solve for exponents, so let's just kind of do it, okay? So those of you, have you guys ever learned these compound formulas back in the day when you were younger in any of your 9th grade class or last year a little bit? No? So are they new to you guys? All right, I want to set up these models. These are going to be models already given to you, and here's something that should lighten your stress. How many of you get a little overwhelmed having to memorize formulas? I do too. Okay. If you feel overwhelmed, we actually aren't making you memorize them. We will give you the formula. You do need to know what the parts are, so you know where to plug in pieces, but you won't have to memorize the formula. You guys just know how to use the formula, or even just solve a part of the formula. In fact, I decided to print the reviews early, so you guys could tinker at them between here and the next week, because your guys' personal test will be by Friday next week for sure. Monday will be a group test, and group tests treat them like they're review days. It's just a review date is to put yourself on the spot. You get to like work with somebody and like actively talk and be partners. And then your job is to take that feedback of what you do and don't know, and then try to kind of like learn from it, okay? And if you guys look at the review questions, look at how easy these are. Everybody turn to the back page. We actually already put most of these in the models for you. So realistically, we're just trying to make you guys know how to use these models. Does that sound good? So I don't think you need to feel overwhelmed. On the homework, we are making you build them yourself a little bit, but really this might be the way you're tested. So I wouldn't really really worry a ton. Does anybody even see Marie, by the way? I forgot to give her one. I'll try to find her. So let's look at this. Now, I do want you to know, even though your models are going to be given to you, I want you to know the parts of it, because when you guys just did that activity and there was like some coefficients, you didn't know what the parts were, right? You were having a hard time knowing, like, I think the 10 point whatever is this. And I want you guys to know what the parts of the equation are, okay? Now, this is for continuous interest. If you guys, do you guys know what interest is, by the way? Has anybody never heard the word interest and doesn't really know what it means? And what do you know about it? Let's do that. What do you know about interest? What is interest? Yeah.
If you put money in, then they'll trade it into stocks, and then the stocks will give you an interest price, and it gives you money, and then if it goes down or something.
Yep, it's something similar. Not everything is dealing with the stock market, but yes. Interest is money earned for it's like letting your money work for you.
Money,
Yeah.
It's like
And
you put money in for
right, you earn money, but also on the negative, if you borrow money, you also have to pay interest. So people who get home loans, credit card debt, all that kind of stuff, whatever that money is that you're borrowing, somebody's like, fine, here's my money, but you're going to pay me for like me loaning you my money. And so that's called interest. Anyway, we have to keep it simple because we're introducing interest to you. You guys, these models are similar to ones where it's like pretend, we're going to do an example like pretend someone's born and they put a lump sum in an account to sit. That's not really likely. I was really poor when I started having kids. I had nothing, no way to put money aside. But even then, people still add money to it as the years go on, and those are annuities, and they're a lot more complex formulas. So these formulas are like, put the money in and sit. Does that sound good? They're like really basic formulas. All right, when you see the word continuous, it'll be this model, where it's P times E to the RT, and the parts of it are going to be this. This is your future amount that stuff grows to. over time after t. This is your guys' initial amount. It's the P stands for principal. So the principal is the amount you put in, and so that stands for initial. Or like if you guys have some credit card debt, it's your initial amount you borrowed. Or like a house loan, it would be what I opened the loan up for. It would be my initial. E is just Euler's number, so it's just a number in your calculator. So that's what E is. So E is nothing like, there's nothing that represents, it represents. R is your rate. Do you guys know what rates have to be in though?
Percentages?
They have to be their actual number though. Because is 10% a number, or what is it as a number? 0.1. So you need to make sure your rate is the actual number, so make sure they are the decimal form. So like 10% as a decimal is 0.10. 3.5% is 0.035. Does that make sense? You need to make sure, otherwise you'll be way, way off. If you guys have to set it up yourself. Like I said, on the review, we're mostly doing it for you. On your homework here, so on 6, oh gosh, I've lost 6.6, where is it? On 6.6, we do on 6.6, here it is. We on 6.6, like gave you the formula to use, but you guys are plugging the pieces in. So we are making you like learn to do that just a little bit, okay? T is what do you guys think? Time. Now, if money is involved, you need to make sure it's in years. Now, if you guys do a real world example, which you're not going to see till you work on the review, because we kind of kept this homework just interest, but like there is going to be like a population one that we make you plug into and whatever. Those ones follow continuous models. So they'll be really similar formulas, okay? Those T's don't have to be in years, because like bacteria growth, are you really going to like calculate that in years, or is that more like hours? Hours. Mosquito population, is that going to be in years, or is that going to be more like days? Days, right? So some of those applied things are all relative, but like with money, it's always years. So if something's going to sit for 6 months in a high interest account, do I plug in a 6, or is it going to be 0.5? Very different answers, right? So you got to be really careful, okay? Now, we're going to hurry and at least set one up together, and I'm not, this one, the way they're asked, you're either sometimes just plugging into your calculator, or you're sometimes going to solve for T. So this one, it says, so Angelina was born and her parents put $3,000 in a college account that will raise 4%. And the words you look for is compounded how, because you're going to learn another compound interest thing, and it's compounded, like they'll give you a number times a year. When they use the word continuously, you get to use this continuous formula, okay, with the E. E is Euler's number that is constant, is present with continuous growth. And so we use E when something's continuous, okay? So here we go. Set it up for me. Assuming there's no deposits or withdrawals, what will the balance be after 10 years? So our model, let's set up our model. What's our amount, or y equals, or f of x equals, or whatever. We're using a, I guess. They're using, let's do let's set up our model first. How much, what's our principal? 3, oh, it's off the screen. Oh, no, it's on the screen. 3,000. And then we get to say E. And then what's going to my R's spot?
4%.
4%.
Good. You have to go 1, 2, 0.0, 0.04, or just 0.04.
Yeah.
Now here's my model, and this is what most stuff's going to be given to you on the test day. Your homework doesn't give, we make you build it yourself. But if I ever want to say, well, what am I going to make in 10 years? Where do I plug in the 10?
T.
To your T. So when we switch this to be the amount after T years, you guys will say, oh, 3,000 E to the 0.04, and then you guys get to plug in a 10. Now, this is just straight plug in. You guys have to be able to plug it in. Now, I do need to go through a solving one, so you guys could attempt. I really want you guys to try a lot of the assignment, because you guys, there is another interest model we didn't get to because they didn't see the tours today. And I really wanted to do that Desmos thing. Did anybody try this and tell me how much these grandparents had in the account for their kid in just 10 years? Not that they're going to give it to him as a 10-year-old. What'd you get?
It was 4,475.
So it grew 4,475.
Yep.
Now, hold on 1 second. How does this change things? Let's take this model down here. How does this change things in this model when I use the word how long will it take the balance to be 10,000?
Did you plug in A to be 10,000?
Yep, you put 10,000 here,
Okay, that
and I am solving for t. So listen before you guys go. Didn't we just solve an exponent problem just like this? And so you're just using your solving skills. What would we do before we walk out? We would divide by 3,000, and that would simplify to like 10/3. So I would get 10, just one more second. I'm sorry for the short day today, but we're now down to converting it to a
E, right?
clear an E by using an ln. So I would be like, oh, I get to ln both sides, or convert it to an ln. If I ln that, it's gone. And then what's my final step?
Oh, that doesn't say out. That doesn't
Divide by
0.04.
0.04. So we would have figured out that it would, and I think this one's like 30 point something. So this stands for, hey, in 30 years, it will grow to $10,000. And so those grandparents have like a $10,000 gift to give to their 30-year-old grandchild, but probably more because I bet they kept money. Okay? So we ran out of time to talk about this other interest model, but they have the models for you in your homework, and we will talk about it. If you can't do it, we'll just talk about it the first of class on Monday and still try to review as a group test day. But view group test days as review days. Like it's like a way to review with a partner